Hello, my dear classics friends. How are you all? Hope you are all doing well. Welcome to StudyMate. My name is Shiva Prasad, and we are almost in February. And we all know that your term exams of your second term are coming near, that is, final exams. You have to cover science, math, social, everything, right? But you don't have to stress because I have brought you the last minute revision of classics science. So, we will be following this your Curiosity NCERT textbook. So this is the first video. We'll be covering temperature and its measurements. So without delay, let's start. By now you all know the concepts of what is hot and what is cold, right? So a freshly prepared cup of coffee is hot and a freshly made ready of ice cream is cold. I'm sure you wouldn't like your ice cream hot and you wouldn't like your coffee cold, right? Although there is a separate cold coffee, but generally the coffee that is prepared at your home is hot. So people like it to be served hot. Not just coffee, the tea, or in your case, most probably you would have drank milk that is warm or hot, and the hot water you drink or the bormita that you drink is generally hot, right? And the ice cream that you eat is cold. So this is the difference that we have. Not just in eating, you would have observed that the afternoon that you have experienced when the sun is above shining on you, and you would have played with your friends in the afternoon, and you would have experienced the sweating and the heat and the uncomfort that you feel because of the hot sun rays that are falling on you. And similarly, when you have experienced early mornings, right? When you have woken up in the early morning, you would have experienced the cold, especially if you have come out and started walking or jogging. And that too, if you would have sat in a two-wheeler and have traveled in the early mornings, you know that you need sweaters, caps to keep you away from the cold, right? So this afternoons and early mornings, the difference is in the heat and the cold that you are feeling. And this becomes especially contrasting if you consider the afternoons of summer, right? So soon summer vacations will be coming. So in summer, the afternoons are much hotter than the already afternoons that you experience, right? And these early morning winters are especially colder in winters. So winters are the months that you just experienced. That is in November, December, January. So these were winters. So here the early mornings are especially cold, right? And the afternoons, which are generally hot, are especially hot in summers, right? Like March, April, May. So this difference will also show in the water that you want to take bath in. Like in the hot summers or in the afternoons, just after you have played, you would like to take bath in the cold water, right? It will feel much relaxing. Similarly, when you want to take bath in the early mornings, especially in winters, you would like to have your water warm, right? If you have the if you feel the water is too cold, you will ask your mummy or papa to get the water heated, or you would mix hot water to it, right? The measure of how hot or cold an object is what we call temperature. So the temperature is the measurement of how hot or how cold an object is. So in chapter 5, you would have learnt about length, right? So length is the measurement of how short or tall something is, or how long something is. Similarly, temperature is the measurement of how hot or cold an object is. So we will be differentiating between this length and temperature. So since you know length, so we will be using it to understand temperature. So let us differentiate between length versus temperature, right? So what are the devices that we use to measure length? We generally use, similarly, we use thermometer, right? So just like we use tape to measure length, we use thermometer to measure temperature. So thermometer is a device to measure temperature, right? Or thermometer is a device to measure how hot or cold an object is, okay? Right. So what are the scales that we use to measure length? Let's say this is the tape, right? So it might be in centimeters, meters, feet, inch. So tape is the instrument but the scale of the readings on that tape might be different, right? So let us list a few examples. So one would be meter, right? Another would be inch. Next we use feet, right? So meter, m is the symbol we use to indicate meter. So for inches we use in, or in some cases we use this double comma, right? So in feet we use ft, or in some cases single comma. So this indicates, single comma indicates feet, right? There are still many other like yard, mile. Similarly, when we talk about temperature, the three main scales we use to measure it are Celsius, right? Fahrenheit, and Kelvin. So these are the three different scales that we use to measure temperature. So these are not the only three, there are still many, but these are the three main scales that is used to measure temperature. So Celsius, we use degree Celsius, right? This is the symbol we use after the reading to indicate that it is in Celsius degrees, right? So we use degree Celsius to indicate the Celsius scale. We use degree Fahrenheit, degree F to indicate Fahrenheit scale, and Kelvin we use just K. There is no degree here. While writing the spelling, actually Fahrenheit is what we spell Fahrenheit, but what I have written is wrong. The actual spelling is Fahrenheit is wrong. The actual spelling is Fahrenheit. So this is the correct spelling, Fahrenheit. So this is our degree Fahrenheit, right? So be careful while writing the spellings, okay? So the names Celsius, Fahrenheit and Kelvin are derived from the scientists who helped in developing them, right? So Celsius was derived from the scientist, Swedish scientist Andreas Celsius. So he was the main scientist behind it. So that's how the unit was named. And Fahrenheit is named after Daniel Gabriel Fahrenheit. So he is from Netherlands, and a British guy named Kelvin is the name behind the naming of this unit, okay? You might be knowing while studying length that meter is the SI unit of length, right? Similarly, when it comes to temperature, Kelvin is our SI unit. So what is the meaning of SI unit, right? SI unit stands for International System of Units. So the need or requirement for having this system was, earlier people of each country used to have their own set of units for measurements, and this used to be a problem when there was a need for sharing of information between people of different countries, especially when the data was related to scientific research and industries. So there was a requirement of standardization of the definition of what each unit stands and which unit will be followed, so that when there is a case of sharing of information, it would be much easier to follow for everyone, right? An institution came into being, which was System A International D Units. So it was, the word was in French because it was a French initiative, and that word in English is called as International System of Units, right? You will learn in future classes, but just know that SI unit is a standard of units. It is made for the convenience of all. Just like we have many different of tapes, whether we are measuring centimeter, millimeter, or meter, or kilometers, we have many different of thermometers. So depending upon the situation and depending upon the temperature range that we are measuring, we have many different of types of thermometers, which we will see in few minutes. Let us quickly see the scale of temperature. Let's see the Celsius scale, right? Let this be 0 degree Celsius, and let this be 100 degrees Celsius. Okay, so 0 degree Celsius is where the water freezes to form ice. So this is also called as freezing point of water, right? So this is where water freezes to form ice. And similarly, 100 degree Celsius is where water boils to form steam, right? So this is called boiling point of water. You will learn more about these things in future classes, but you can just know that this is called this and this is called freezing point of water, right? So does this mean that there is only, the scale is only from 0 degree to 100 degrees Celsius? No, we have the temperature or degree Celsius less than 0, we call sub-zero temperatures. So it can be minus 20, minus 40, right? So there are places in the world where the regular temperatures are 0 or 20, minus 20 degrees Celsius, minus 40 degrees Celsius, right? Similarly, we have so many temperatures which are above 100 degrees Celsius, especially in industries like in steel industry, coal manufacturing, and petroleum. The temperatures reach to 600, 800, and sometimes even 1000 degrees Celsius. So that's how much hot the industries or the furnaces there are. Okay, right? So the room temperature, generally where we sit or where we study, the general temperature of our rooms in our houses are generally 20 to 23 degrees Celsius. This is our room temperature, right? And from 35 to 42 is the range of human body, normal human body temperature, right? Let's write it here. So this is not exact. So 35 degrees Celsius to 42 degrees Celsius is generally what we call range of normal human body temperature. Okay, and even in this, taking all the averages, because depending upon the age of the person, depending upon the time of the day we are measuring, and depending upon the work that he has done immediately prior to that, so the temperature of the body changes. This is the general temperature, and on an average for humanity, so the average temperature of the human body is considered to be 37, right? 37 degrees Celsius is the average human body temperature. Okay, so this was in degree Celsius. If we write this in degree Fahrenheit, this 37 degrees would be 98.6 degrees Fahrenheit. So the average temperature, the average human body temperature in terms of Fahrenheit is 98.6 degrees Fahrenheit. Similarly, 0 degrees is 32 degrees Fahrenheit, right? 0 degrees Celsius would be 32 degrees Fahrenheit, and 100 degrees is 212 degrees Fahrenheit, right? Again, as I said, this any degrees Celsius can be converted to Fahrenheit. Okay. Similarly, in Kelvin, 0 degrees Celsius would be 273.15 kelvins, and 100 degrees Celsius would be 373.15 Kelvin. So as you can see, there is a difference of 100 readings. So for every 1 degree increase or decrease in Celsius, there would be 1 degree increase or decrease in Kelvin proportionately, right? So 0 degrees Celsius is equals to 0 plus, we can write it as 0 degrees Celsius is equals to 0 plus 273.15 Kelvin, and 100 degrees Celsius is 100 plus 273.15 Kelvin, that is 373.15 Kelvin. So here we can derive a formula. Whenever converting from Celsius to Kelvin, we can just add 273.15 to it. So for any degree Celsius, if we add 273.15, this resultant would be in Kelvin, right? So this is in Kelvin. Okay. Similarly, we can change the reading from Celsius to Fahrenheit, Fahrenheit to Kelvin, Kelvin to Fahrenheit, Fahrenheit to Celsius. So we have formulas for that. You will learn in higher classes. Degree Celsius is what we majorly use here in India while doing the weather reports or for the instructions for cooking, or even in the packaging, we mainly use degree Celsius. So that is the standard thing we use for our everyday life in India, right? And degree Fahrenheit is what the people in United States majorly use, be it there for weather or instructions for cooking or in the packaging, everything they use degree Fahrenheit. So Kelvin is mainly used for scientific purposes in science research articles or measurements with respect to experiments, especially when the temperature is low. We use Kelvin because Kelvin is more exact and more precise. So the word thermometer is derived from thermo and meter. Thermo means something related to heat, right? So it indicates heat. So you have heard words like thermos. Thermos is a portable container where the if the water or tea or coffee is warm, it keeps it warm for a longer time. Or if there is a fluid or a juice that is cold, it keeps that temperature, that is that coldness of the juice for longer time. So we call it thermos. And generally we use thermals in winter, especially in northern parts of India or where there is heavy snowfall. So we use thermals. They are the inner garments which keeps the body's heat intact, right? And meter is nothing but measurement or measuring. So do you can you recall the words using meter? You have learnt perimeter, right? Perimeter is the measurement of the surrounding of any geometrical object or any object or any given place, right? So meter means measuring. We have many words with meter: odometer, speedometer, right? Okay. So as I said, there are many types of thermometers. We'll look into them one by one. In the textbook, they have given two types of thermometers, right? One is clinical and the another one is laboratory thermometer. So as I said, the average human body temperature ranges from 35 degrees Celsius to 42 degrees Celsius, right? So when we are measuring the human body temperature, generally it will be within this range, right? So if we have the readings from 35 degrees to 42 degrees Celsius, that is enough to measure the human body temperature. So this thermometer is used for clinical purposes and we have quite a few types of them. The one that is given here was mercury based. So this bulb has mercury and depending upon the heat it gets liquefied and it goes here, right? So depending upon particular heat that it gets, it will reach a particular point. So as you can see, they have marked 37 in red. So that is the average human body temperature. Okay, but the mercury based thermometers are not safe. So it is highly poisonous. Mercury causes poisoning in our body, and for that, especially because these thermometers are in the glass casing, there is high chance of them falling down or breaking and the mercury being spreading. So that's why instead of mercury, we use alcohol based thermometers. More common than mercury based or alcohol based thermometers, we see digital clinical thermometers. So you might have seen this. So this is the tip. So instead of the bulb which contains mercury or alcohol, here there is a tip, right? And the reading comes in as digits. So with respect to the mercury based thermometer, this is cheap, relatively cheap, of course relatively safe and easy to use, right? Apart from this, while reading the glass based mercury or alcohol based thermometers, we need to be very careful getting the readings, because if the angle of the sight that we are seeing is different, the readings might look different. So there is a chance of mistake. But in digital thermometers, since the reading is easily shown in the display, it is easy to read for us. Okay, and another advantage is it will show, depending upon our settings, it will show either in Celsius, Fahrenheit or Kelvin. Okay, so in clinical thermometers, we saw there was mercury thermometer, but the substance mercury is extremely toxic to us. So instead of that, people generally use alcohol based thermometers. We also saw digital thermometer where the tip has the heat sensors. So based upon that, we'll get the readings in the display. And we also have non-contact thermometer. So especially when there was COVID, so this is the diagram that is given in your textbook. So when there was COVID, the touch or the contact of the patient while measuring the temperatures might have led to the spread of the disease. So in such cases, instead of touching the surface to find the temperature, because all these other things like mercury thermometer or even in digital thermometers, the temperature is obtained by touching the surface. So depending upon the touch, whatever the reading shows, that is the temperature. But in case of no contact thermometer, or the technology is based on infrared, so we also call it infrared thermometer. There is no contact between between the object of which temperature is measured and the thermometer. So without contact, the temperature can be measured. So you will learn about this in future classes. So this is also called infrared thermometer. It helped in lowering the risk of spreading the disease at the time of COVID. Right. So laboratory thermometers. So this is the image given in your textbook. So it is a bit longer, and here the reading starts from -10 to 110. So generally in laboratory thermometers, the range of the temperature that can be measured is generally from -10 to 110 degree Celsius, or still lower, because it depends upon the specific purpose it is being used. And again, the thermometer that is used for laboratory purpose may be the bulb based thermometers. So in that case, the material that is contained in the bulb might be mercury or alcohol, right? Or it can also be digital or non-contact thermometers. But anyway, in laboratory thermometer, the range is high. That is the difference between the clinical and laboratory thermometer. Sometimes depending upon the situation, it needs to be very precise, super precise, right? Okay. And other than these two, sometimes we also use a thermometer to measure the temperature in the room that we reside. So we call it room temperature, room thermometer. Right. So this would be generally hanged to the wall. So here as you can see in this room thermometer, the range of temperature starts from -10 to 50. Right. I was in Delhi once, so at that time the temperature was 42.5 degrees Celsius. At that time it was a very high temperature. So that was outside. Actually in the room generally it will be cooler, but in any case the range of the room temperature might be generally 20-25. So in general, to find the room temperature, we use room thermometer. That's it. Just like here, to find the temperature of human body, we use clinical thermometer. To find the temperature at room conditions, or at home, or at hospital, or at any place, we use room thermometer, right? And as we saw in your textbook, the range was from -10 degrees Celsius to 50 degrees Celsius. And as I said, non-contact thermometer is also called infrared thermometer. So it's also called infrared thermometer. These were the main things that were given in the textbook. Thank you for watching this video. If you found this video useful, do like, subscribe, and share this video with your friends. Thank you.